Okay, at this time, let's take a look at number 5. Okay, number 5 from your 3.1 homework. Number 5, once again, you're finding the derivative of the function f of x, but using the alternate definition instead of the original definition. So 3.1, number 5, you're given the fact that f of x equals 1 over x. You're concerned with finding the derivative at a is equal to 2 using the alternate definition. So what you could start is you're basically finding f prime of 2, which is the same thing as saying that the limit of this as x approaches 2 of f of x minus f of 2 over x minus 2. And f of x, as you can see it's just 1 over x minus f of 2, which will be 1 over 2 all over x minus 2, and we're still finding the limit of this as the x value approaches 2. So let's see what we could do with this then. Okay, so limit as x approaches 2. We still cannot substitute 2 in place of x, so somehow we have to simplify this more. The way that you could do that is to try to combine these two fractions, okay, these two rationals right here, 1 over x minus 1 over 2. To combine those two fractions, you need to have a common denominator. So in turn, I need to multiply the left fraction, the first fraction, by 2 over 2 to have 2x on the bottom, and the second fraction by x over x to have 2x on the bottom. So it appears to be 2 over 2x minus x over 2x, which becomes 2 minus x all over the common denominator of 2x all over x minus 2. And then let me use this space right here. Okay. Now we have a complex fraction here, a fraction inside of a fraction. A fraction just refers to a fraction implies division. So what we're doing, all that we're doing is dividing the fraction of the numerator by x minus 2, and again we cannot abandon the limit notation yet, but when you're dividing by something, you can multiply by the reciprocal of the same thing. And then this is where it gets a bit tricky, something that you've seen before, I don't think this is going to be a surprise. You should know that 2 minus x is related to x minus 2, because I could rewrite 2 minus x as negative 1 times x minus 2. I'm just changing the signs of that by taking out a negative. And in doing so, I could cancel out the x minus 2's. So you're only left with negative 1 over 2x. And this is where now you could use the direct substitution method to figure out to evaluate the limits. So your final answer comes out to be negative 1/4. And let me see if that's the answer. Negative 1/4 is indeed correct.